Hi and welcome to this video in the Dcl Understanding Concept series, and in this video we're going to be looking at reading Excel data. Now from time to time we get asked, is it possible to read Excel data straight into Dcl? And the answer is yes, it is, but there's a few techniques that you have to learn to be able to do that, one of which cuts across using EPS, the Excel productivity scripting tool within the program, and it is a separate set of videos that are available to teach you that if you're not familiar with EPS. In this video we're not going to look at EPS except just to use the basic tools to do what we want to do here by reading from this Excel spreadsheet. We're not going to explain how EPS works. They're covered in separate videos. Now this video is going to be split down into some distinct sections. The first part of the video, we're going to look first of all at a very simple tool which we offer free of charge, which will convert this Excel data into Ascii so that you can just have a map that's produced and then just write a script that will read the Ascii data. So that's one way of working where you go through a conversion process. The rest of the video will look at how you can read Excel data directly into MRDCL. Now, that requires understanding a little bit more about how MRDCL reads and writes data, and it uses actually a trick to be able to read this Excel data, and we're going to take you through that step by step just so that you understand the principles of how MRDCL reads and writes data, and then we apply it to the Excel data. So let's kick off with putting this data into a spreadsheet, from a spreadsheet into an Ascii format, and that simply uses a free utility that you can get from us. And all we do with that is that we will just copy this data in this spreadsheet. So this is a typical, albeit small file here, which has got 18 records with 6 fields: serial, gender, age, Q1, Q2 and Q3 in it. And I'm going to use the free utility which is called output ascii.xlsm. So that comes with a free macro, and you can see when I open it up here, when you open up the program, you'll see when you open up this workbook that you get a list of instructions on how to use it. So that's the first thing that you do, and it will produce a map in a minute, but I will need to paste this data from here into this particular workbook. You'll note it must have a heading in row 1, and that's true of everything I'm going to show you today. It's essential that there's a heading in row 1 and then the actual data starts in row 2, and I won't repeat that in future, but it's a mandatory aspect of the file. You must have that header. I'd also suggest that it's also good practice not to have gaps in these names. That there, if you want to have words, you could put underscores in to connect them. So if you wanted to have spontaneous recall as a name of a field, you might call it spontaneous underscore recall. Okay, so we put this data into this worksheet here. We've called it sheet 1. And we now can go to the control worksheet, and it'll pull up a list of the sheets in the workbook. We can click on the sheet that we want to convert to Ascii, and we just simply click on this button. Now what this program does is it's going to make me a data file here, which I've made, and what it's doing is it's checking each field to see the maximum width it needs to be. So if there was a number 100 in there for someone who's 100 years old, it would make that field 3 digits wide. And what it's given me here is a map. So it's telling me the serial number from sheet 1 is a width of 2 that's gone into columns 1 to 2. Gender's a single digit, so that's gone in 3. Age is 2 digits, so that's taken up 4 and 5, and so on for question 1 and question 2. And now we have an Ascii file that we could write a script for to read gender, age, Q1, Q2 and Q3 in the normal way. So that's one way of working, that we could use that utility to make the data, and indeed I've got that data file that we made there, which I can open with an editor, and you can see there's the file that we exported from the Excel macro called output ascii.xlsm, and it's made an ASCII file, and we could write a script to use that. All right, well, the rest of the video now we're going to look at how you can read Excel directly into the software and process it. Now, what we're going to use is EPS, which is the technique that MRDCL has for reading anything from Excel. That it might be code lists, that might be any other instructions that you've got, but in this case, it's data. But first of all, I want to explain how MRDCL works. Now, this might seem remarkably obvious to some people, but other people might not be aware of this. So we're going to look at a test project. And we're going to look at a project here called data.stp, which actually is used in one of the other videos. And it's just a perfectly normal script. It's got some questions in it, and then it goes on further down, hits finish data, and writes away records and has some tables. But I just want to consider here what actually is going on when MRDCL reads this ASCII data file. So we've got an ASCII data file here, which I think has got 831 records in it. And what's actually happening when MRDCL runs is each time it hits start data, it's reading another line from that ASCII file. And each time we hit finish data, it's writing a record away. Now that might sound very obvious to many users, that starts reading a record and finishes writing one away. But in this particular case, where we want Excel data, I don't actually want that to happen. I actually want to read the Excel file from the top to the bottom and write away a record for each line in the Excel file. And the way we do this is by cheating a little bit. So let's close that file now and just quickly run it, and you can see what's happening here. It is, as I explained, really 831 lines in that ASCII file, writing 831 IDF records. And when we run our tables here now, we can just run that, and sure enough, we've got 831 records in this particular table, as we would expect. All right, now let's just consider how we're going to do this when we come to reading an Excel file. What we're actually going to do is read a dummy record from the ASCII file, but then go through the worksheet and write away a record for each line in the worksheet, excluding, of course, the header in row 1. So let's open up a script now, and this is a script that's going to read my Excel data that we looked at just now. So here's that Excel data. We'll shut this workbook and we'll return to this data here that we've got. Now what I'm going to do this time to do this is I'm going to say that the data file is dummy.asc. So let's look at dummy.asc. Here it is, and it's just one line with rubbish in. Now don't put a blank line in there because MRDCL may ignore it if you haven't got the right run control parameters. Just put something in there. I put in 111. It can be anything you like. It can be a longer string than that. It could be one character even if you like. But I've got a file in there and one line. It must be one line. I don't want two lines, and I'll explain why just in a second. What this is going to do is that when it hits start data, it's going to read that one line in there. Now, whereas in the previous example, it would have gone to finish data, and if it had read that line, written one record to the IDF, and that would have been the end. What we're going to do here is we're going to trap it in a loop that reads the Excel workbook called data.xls. Now, this is going to use EPS to do this. But effectively what we're doing between these lines of code here, between the start of the loop or the opening of the DB loop, opening up the workbook called data.xls and the worksheet called data, I'm going to loop through here as many times as there are lines in that file, less 1 of course for the header, and I'm going to write a record away for each line in that Excel file. So where we have 18 records in that Excel file, it will write 18 times. And the reason it does this is that when MRDCL finds a write command, the finish data command does nothing more than indicate it's the end of the data stage. So the finished data won't write anything away, but this write command will write away the 18 lines in my Excel file. Now we have to approach this a little bit differently from normal. What we do here is we write a dummy definition of the variable. So we di serial $serial with just a comma on the end to dummy define it. We give it a title. We put in the variables here. So we say that gender has just 2 responses. There's a text, there's the title, and so on by dummy defining every variable that we're going to be picking up in our data file. Now when we come to read the data, we're actually going to force the data using defines and make statements from the data that we're reading from the worksheet. So this is opening the workbook, this line. We're going to go through the worksheet called data in the workbook called data.xlss. Now, as I say, this is using EPS, and I don't want to focus on the EPS script from this because there's other tools in EPS and other videos that cover how to use EPS in detail. We're just going to look at the tools that are needed to complete this task. Now, if we look at our spreadsheet, we want to pick up all these numbers here. So we want to pick up the serial number. So what I'm doing here is I'm setting an index called serial to pick up what's in the column headed serial. Now we could have given that a different name. I could have called it serial ID, and down here I would have then picked up serial ID, but we haven't done that, so we're going to just leave it as serial because you can use the same names for the index that you're saving it to and the column that you're picking it up from. So this is going to set serial to the value in the column headed serial in the workbook, and it's going to set an integer to the value of serial. So in the first, when it's reading row 1, it'll be 1, 2 for row 2, 3, 4 down to 18. Likewise for gender, we're going to pick up gender into an index called gender, and we're going to set gender to be blank dot whatever value is in the gender column, 1 in this case, 2 in this case, and so on. Likewise for age. Now when you get to question number 2, that we'll see in the worksheet here is optional. So only if they said yes at question 1 or 1 at question 1 do they answer question 2. Now we have to make a contingency for that, otherwise the script won't work if there's a blank in there. So what we do in here is we say that if the field Q2 is blank, don't do anything. Now, it'll be good practice to start off by actually making Q2 blank first of all. And the reason for that is if we're not careful, if that field is blank, we might carry through the value from the previous respondent. In fact, we would carry through the value from the previous respondent. So I'm going to make it blank and then say if there's something in the column headed Q2, then set it the index Q2 to the value and then make it, and likewise for Q3. Finally, you can see I've got a variable here called vAge, which groups the ages into some ranges so that we got a variable called vAge, and that's just appearing like a normal variable. And then of course we need that write command to write it away. So let's save that and let's run it. And sure enough, we have 18 records, and there's our data coming out looking like the tables we would expect. Looking at the listing file might bring this to life for you. So if we look at the listing file, you can see at the top here, we've got the dummy definitions, and then we've got the data that's been picked up from the spreadsheet. So we're defining serial equal to 1, We make gender blank and 1. We define the age as 33, and so on for each of these fields. Reading across here, getting all that data for serial number 1, and then we're going to repeat that for serial number 2 down here. And there's the code that the EPS script has generated for us, and it's going to do that for all 18 respondents. We go down to finish data, and there we'll find the 18th respondent, which it also writes away. And so that's how it's writing it away, by having 18 write commands in here. And the table stage just looks like any other table stage that you might have encountered when using MRDCL. So that's a very practical way of writing a script that will read a worksheet. It can be a little laborious because all that script is, every column you'd need to specify with a little bit of EPS script. So there are ways of improving that. Now I've just extended this little bit example for the videos, the files that go with the videos here. You'll see there's a much bigger example which you're welcome to use and work with. So this particular file here is called Big, and if we open it up, you will see that it contains, I think it's 30-odd thousand records in here. So this one here now has got 100 questions in here, and it's got 34,000 records in there. And all that we've got here is the same script, but reading all the questions. So it just goes on and on, but it's going to be exactly the same script in terms of appearance, except it's picking up all 100 questions. But of course, the listing file now is quite enormous because it's got 34,000 times the code in here. So if we scroll down to halfway or something like that, you can see it's making all these values, and eventually it writes another serial number out from the file and makes all the values. It's only a dummy file. Now I'm not going to run that here because it does take a bit longer to run. You will find it slower to run or pick up the data, read the data, not the tables, than a conventional Ascii file. But I found this quite efficient. So just to look at this, you can see it started here at 1648 and finished at 1650. So it done it in just under 2 minutes. It read 34,000 records for about 100 or so fields. So it was very quick, and you can work with that script there if you want to use it outside the video. Now, writing that script wasn't, I don't think, the easiest script you've ever seen. So we've developed it a step further, although you might need to develop it yourself yet another step further. And here we've got some much cleverer EPS script that's extending what's going on here and making it a much more concise and easy to use tool. If we go back to the workbook data.xlsx, and I open that now, so it's just opening for me, you'll find that next to this worksheet here, I've got a worksheet called Control, and this worksheet is being used to control how data, the worksheet data, is actually read. And there will be now an MRDCL script that will read the control worksheet that will in turn tell it how to interpret the data worksheet. Now this makes it much easier to use because here we've got the fields here. So we could, for example, just copy this and paste special with transpose here, and that will get the fields. And then we'd need to tell it what types of variable or data we're picking up. So some of these are integers and some are single in this particular case. You could extend this functionality so that it picked up multiples, for example, that may have had fields called Q4_1, Q4_2, Q4_3. So that was also automated, but this particular tool doesn't quite go as far as that. In here, we put the question title, and in here, we've told it how many codes there are. So in the case of the single, gender has 2, question 1 has 2, and question 2 and 3 have 5. And then whether data is optional for these fields no in the case of these, and yes in the case of this one. You could, of course, just make everything optional and skip round if there's no data for every question. So let's look at the script and how this is working. So what we have now, and this is how EPS works, of course, for those who are not familiar with EPS, we're developing a generic script that can be used with any workbook, provided the control worksheet has been completed and the data sitting in a worksheet called data. Although we could make that flexible as well, of course. So this piece of code here is just telling it what to do to read the control worksheet, and you would never touch this. In here, you can see the texts are being entered. So $gender, we do need to put the variable or the question name in here. Otherwise, if we just have lots of X variables, it will confuse MRDCL and you'll get errors. It will assume it's applying to the last dummy defined variable. So $gender has male and female, $Q1 has labels like that, and so on. And then everything else is just using generic script that you'll never use or never look at again. Now in here we've entered any variables, and you can see there's a note, and what the note is saying here is that it would be more efficient to put your variables in the table stage, because it's going to write this script every time for every record. It's going to repeat it. Now if you had a lot of variables in there, that might slow down the run even further. Although I think 2 minutes was quite good for a big data file just now, but it would impact if you had lots of variables in there. But of course, if you needed them on the IDF so that you can export them, for example, you would need to put them there. But my advice otherwise would be to put them in the table stage, because the way MRDCL processes, that would be a bit more efficient. And sure enough, if we run this now, we should get it reading those records, and we're getting the same tables up, but this time it's all controlled by the control worksheet. So you could adapt this further, just to sort of go another step further here on what you could do. So we haven't got a tool in here for reading multis, so we could, for example, develop this so that there was a way of picking up multis, Q4 reasons, and we might tell it that there's 20 answers, and yes, it's optional. But of course, the EPS script would need to be added to handle multis, so that it knew it had to read perhaps 20 fields called Q4_1 to Q4_20, and then put them together as one variable so that they were easily analyzable in MRDCL. So that this template could be extended quite easily to cope with the way that you store multi-coded data, or indeed any other forms of data or ways that you store variables. And indeed, multis can be stored sometimes as 1.2.3 if a respondent has codes 1, 2, and 3. Again, the script that's generated looks just like the same script that we generated before, slightly different because we've got the text here. So what's coming out is dummy definitions at the top, the texts being entered here. It would be possible, of course, to develop the EPS template so that the texts were in a worksheet, for example. So gender was in a worksheet called gender, and that was automatically read as well. And here we define the serial number and so on, and it's generating everything that we want to run that script and produce the tables correctly. Well, that completes this video on handling Excel data in MRDCL. It's a little bit of a trick, but it works very, very efficiently and allows you to handle projects where the data is natively in Excel. You may want to extend this template if you've got data in different forms, and that would be dependent on how you store particular types of data and what you want to happen at the back end. But it could be a generic script that then you could apply to any projects. But if you're not familiar with EPS, you may want to learn more about it. There's a series of 7 videos on the website where you can find out more about EPS. Thank you.